Hello and welcome to another one of D's ADD videos. Today we're going to look at another approach to calculating limiting reagents and theoretical yields. The first method I used grams to grams of reactants and then compared what we have to what we should have to determine limiting. Now what I'm going to do is use mole ratios to give me moles of products given the scenario I started with each of the limiting reagents. Alright, so here's this problem that we're going to do, and here's the concept behind it. We're going to calculate moles of each reactant. That's step one. After we calculate the moles of each reactant, we're going to use the stoichiometry and the coefficients of each reactant to convert the moles into moles of product. So we have moles of reactant from step one. Now we convert them to moles of products in step two. The smallest answer is thereby the limiting reagent. So we can then use the mole ratio of that limiting reagent to calculate the mass of the product. And the way we do that is we multiply the moles of the products that we got from step two, specifically the one that came from the limiting reagent, by the molar mass. This will be your theoretical yield. The rest of the problem is the same. You just take your actual, which is given in your problem, divided by your theoretical, which you just calculated, times 100. So again, let's look at this problem. We had 12 grams of one reactant, phosphorus, 35 grams of the other reactant, chloride, and this is our actual yield right here. Okay, 42 grams of the phosphorus trichloride. So now let's see it in action. Method 2, here we are. Step 1, find the moles of each reactant. You take the molar mass, put it in the denominator, and moles goes on top. Same thing if you divide by molar mass, because the moles inverse will flip and multiply. This is just a little easier for people to visualize the units canceling and seeing what's left. So the grams of chloride cancel. Notice that I multiplied the 35.453 that you find on your periodic table for chlorine by 2 because it's chloride. All nonmetals exist as diatomic elements, meaning they're bonded to themselves. So there's 2 of them there. And then if you do the same thing for phosphorus, you get this many moles of phosphorus. And then step 2, if you remember, was to convert each mole given to the moles of product. So moles of product was obtained by looking at the answers from step 1 and the balanced equation given here. So the moles from the equation is 2 moles for phosphorus and 3 moles for chlorine. So if I use that information, I use a mole ratio of 3 moles for chlorine to that of the product, which was 2. So we got 2 moles of product, 3 moles of chlorine. Why did the chlorine go on bottom? Because it has to cancel with these moles of chlorine there. And then 2 moles of phosphorus for every 2 moles of PCl3. When we do that, we have 2 different answers. The smallest one of these 2 answers is going to be the limiting. In this case, we have the chlorine found to be limiting, and thereby making the phosphorus in excess. Finally, we use the limiting moles of product to convert into grams of product to find our theoretical yield. So that it was the answer from the previous step. Then I multiplied by the molar mass. So if you take phosphorus plus chlorine, 35.53 times 3, the chlorine only, and then add the phosphorus, you get the molar mass that I've written here of 137.3 grams of PCl3. And when you multiply, you get this number here, which you round to 45.2 grams. All right? So that's the different part. That's how it differs. So calculate moles of each reactant, then convert to products. Smallest is limiting, then convert that into grams. After that, it's just like what we were doing before in the percent yield problem. Once you know the theoretical yield, you just take the actual that was given in your problem. This is something you created in your experiment, and divided by your theoretical times 100. Okay? So that's the second method. I usually use the first method if I'm given grams to start out with, and the second method if I'm given moles to start out with. And I usually do it both ways just to check my work. It's better to err on the side of caution if to err at all, which is a fancy way of saying better safe than sorry. Practice, practice, practice. If you prefer one method over the other, make sure you just stick to it. Thank you and have a nice day.